All right, so 5% of the natural hair theory for the Ohio Cosmetology and Barber Board natural hair theory exam is chemistry. So basic chemistry, particularly pH. So that's what we're going to go over right here. I'm reading out of the Milady's Foundations book, chapter F6, Chemistry and Chemical Safety. Describe potential hydrogen and how the pH scale works. Although pH, an abbreviation for potential hydrogen, is often mentioned when talking about beauty products, it is one of the least understood chemical properties. Notice that pH is written with a small p, which represents a quantity, and a capital H, which represents the hydrogen ion. The term pH represents the quantity of hydrogen ions. Understanding pH and how it affects the hair, skin, and nails is essential to understanding all beauty and wellness services. Water and pH. Before you can understand pH, you need to learn about ions. An ion is an atom or molecule that carries an electrical charge. Ionization is the separation of an atom or molecule into positive and negative ions. An ion with a negative electrical charge is an anion. An ion with a positive electrical charge is a cation. Some water H2O molecules naturally ionize into hydrogen ions and hydroxide ions. The pH scale measures these ions. The hydrogen ion, H+, is acidic. The more hydrogen ions there are in a substance, the more acidic it will be. The hydroxide ion, OH, is alkaline. The more hydroxide ions there are in a substance, the more alkaline it will be. pH is only possible because of the ionization of water. Therefore, only products that contain water can have a pH. In pure distilled water, each water molecule that ionizes produces one hydrogen ion and one hydroxide ion. Pure water has a neutral pH because it contains the same number of hydrogen ions as hydroxide ions. It is an equal balance of 50% acidic and 50% alkaline. The pH of any substance is always a balance of both acidity and alkalinity. As acidity increases, alkalinity decreases. The opposite is also true. As alkalinity increases, acidity decreases. Even the strongest acid also contains some alkalinity. The pH scale. The pH scale is used to measure the acidity and alkalinity of substances. It has a range of 0 to 14. A pH of 7 is a neutral solution. A pH below 7 is an acidic solution. A pH above 7 indicates an alkaline solution. However, 1 point of pH difference is more than it looks. Because the pH scale is a logarithmic scale, a change of one whole number represents a tenfold change in pH. This means, for example, that a pH of 8 is 10 times more alkaline than a pH of 7. A change of two whole numbers represents a change of 10 times 10, or 100-fold change. So a pH of 9 is 100 times more alkaline than a pH of 7. Even a small change on the pH scale represents a large change in the pH. The pH is always a balance of both acidity and alkalinity. Pure distilled water has a pH of 7, which is an equal balance of acid and alkaline. Although a pH of 7 is neutral on the pH scale, it is not neutral compared to the hair and skin, which has an average pH of 5. Pure water with a pH of 7 is 100 times more alkaline than a pH of 5. So pure water is 100 times more alkaline than your hair and skin. This difference in pH is the reason pure water can cause the hair to swell as much as 20%. pH in skincare products. When the skin is exposed to extremes in pH levels, dryness, dehydration, inflammation, and even bacteria can grow if the product is incorrect for a given skin type. It is important to use products that contain the proper pH for any given skin type. For example, if a client has dry, dehydrated skin, giving that client a product that is too acidic could further dry and irritate their skin. Conversely, if a client has an oily skin type, a product that is slightly alkaline may contribute to oil and sebum buildup and possibly create acne. This client may need a product with more acidic pH. Acids and alkalis. All acids owe their chemical reactivity to the hydrogen ion. Acids have a pH below 7. Alpha hydroxy acids, derived mostly from milk or fruit sugars, are examples of acids often used to exfoliate the skin and to help adjust the pH of a lotion, conditioner, or cream. Acids contract and close the hair follicle. Acids contract and close the hair cuticle. One such acid is thioglycolic acid, a colorless liquid or white crystals with a strong, unpleasant odor that is used in permanent waving solutions. Glycolic acid is an alpha hydroxy acid used in exfoliation and to lower the pH of products. All alkalis bases owe their chemical reactivity to the hydroxide ion. Alkalis are compounds that react with acids to form salts. Alkalis have a pH above 7. They feel slippery and soapy on the skin. Alkalis soften and swell hair, skin, and cuticle on the nail plate and callus skin. All alkalis, also known as bases, owe their chemical reactivity to the hydroxide ion. Alkalis are compounds that react with acids to form salts. Alkalis have a pH above 7. They feel slippery and soapy on the skin. Alkalis soften and swell hair, skin, the cuticle on the nail plate, and callus skin. Sodium hydroxide, commonly known as lye, is a very strong alkali used in chemical hair relaxers, callus softeners, and drain cleaners. These products must be used according to manufacturer's instructions. It is very important that you do not let these products touch or sit on the skin as they may cause injury or burning sensation. Sodium hydroxide products may be especially dangerous if they get into the eyes. So always wear safety glasses to avoid eye contact. Consult the product's SCS for more specific information on safety use. So that is all that we're going to cover for chemistry